Hello everybody, this presentation is for my Year 12 Math Methods students. What I'm doing again is focusing a little bit more on exercise 2C about linear equations. Now the first one I've chosen to do is an example I've made up, and it's to find the equation of a linear graph, a straight line, parallel to this one here and going through this point here. Well, let's start out by finding the gradient of this line here. So if we have 2x plus 3y equaling to 6, what we can do is we can take the 2x across to the other side, so I'll end up with 3y is equal to minus 2x plus 6, and I did that by minusing 2x on both sides. Now minus 2 plus 2x minus 2x cancels out and just leaves the 3y on its own. Now if I divide both sides by 3, I'll get y on its own, because the 3's will cancel out, and I'll get minus 2/3 of x, and 6 divided by 3 is 2. So the gradient of my line is minus 2/3, the number in front of the x there. Right, now the equation for the line that I want to find will have this gradient and go through this point. So if we say y equals mx plus c, and in place of the gradient we put in minus 2/3, and then we substitute in this point where y is equal to 4 and x is equal to 7, we'll be able to figure out c. Now let's see, that will be minus 14, because 2 times 7 is 14 over 3. And I'll get c on its own, and that'll be 4 plus 14 over 3. So c will be equal to 26 over 3. So the equation for the line that I'm looking for is minus 2/3 x, the gradient is there, plus c is 26 over 3. Okay, well in this second problem what we want to do is to find the distance between the points -1, 4 and 5y, and we know that it's 10. So if we're using the distance formula, and I guess we could do that in this case, we could say y2 minus y1 squared plus x2 minus x1 squared. All I'll need to do is say this is point number 1, here's x1, here is y1. Here's point number 2, and here's x2, and here's y2. Now if I substitute in those things, now let's see, y2 is y minus y1 is 4 plus x2 is 5 minus x1 is minus 1. And the distance between these points is 10, so I can substitute that in as well. Now let's see, y minus 4 squared. Now, minus and minus is a plus, 5 plus 1 is 6. 6 squared will be 36, I think. So, y minus 4 squared plus 36. Now I'll square both sides to get rid of this square root, so that'll be, well, 10 squared is 100. And the square root, or the square of a square root, is just the original function like this. Okay, so I'll have y minus 4 squared plus 36. Now if I take away 36 from both sides, 100 take away 36 is 64, and y minus 4 squared, well, alright, a little bit more up here. Now what I can do is I can say, well, y minus 4 will be equal to plus or minus 8. So I can take this minus 4 across to the other side by plussing 4 here and plussing 4 on the other side. So it'll be y is equal to, oops, forgot to change my colour, 4 plus or minus 8. So y could be equal to 4 plus 8 is 12, and 4 minus 8 is minus 4. So there are two answers. Y could be equal to 12, or y could be equal to minus 4. Okay, everybody, this is a question from the book. So you might need to refer to your text. It's from 2C, question 20, and it involves 3 points, A, B, and C. And the first part of this question is find the perpendicular bisector between points A and B. Now I've got a couple of things here I need to do. So the perpendicular bisector, 1, I'm going to need to find the gradient. 2, I'm going to need to find the midpoint. And 3, I'm going to need to find the equation. Now, let's see. Let's maybe start out with the gradient. So I'll call this point y1, a point 1, and b point 2. So the gradient will be y2 minus y1 over x2 minus x1. So let's see. y2 will be 5 minus, and y1 is 7. Over x2, well x2 will be 7 minus x1, which is 1. So that would be 5 take away 7 is minus 2. 7 take away 1 is 6. So the gradient is minus 1/3. But remember, we're after the perpendicular bisector. Now that will mean that if I say 1... If I remember this rule, m1 is equal to negative 1 over m2 when the lines are perpendicular. That would mean m1, the gradient for my perpendicular line is minus 1 over minus 1/3. Now a minus... Okay, so this is the second part of question 20 from exercise 4C. Now what that says is to find the point of intersection between the perpendicular bisector, which was from memory 3x minus 6, so it's the perpendicular bisector, and the line that connects points B and C. So let's see, B and C. So if B is equal to 7,5 and C is equal to 0, negative 2, I can find the equation for the graph that goes through this point and this point. So the gradient m would be equal to, so y2 minus y1 over x2 minus x1. So that would mean the gradient would be 5 minus negative 2. If this is point number 2 and this is point number 1. 5 minus 2 and 7 minus 0, so let's see. Minus and minus is a plus, so 5 plus 2 is 7. 7 take away 0 is 7. So the gradient is 1. Now that means if we have y is equal to mx plus c, where the gradient is 1, and it goes through the point 7, 5, in place of y, can go 5, I'm using this point here, and in place of x goes 7. So that would mean 5 is equal to 7 plus c, which would mean c would have to equal to negative 2. So the equation for the line that goes through B and C is x minus 2. Now we want to know where this line and this line intersect. So if we said, okay, y is equal to x minus 2, where do these two lines intersect? Well, if this is y and this is y, surely this and this would be equal. So if I said 3x minus 6 is equal to x minus 2, now I can do a little bit of algebra. What I'll do is I'll put plus 6 on this side and plus 6 on this side, and I'll take an x away from there and an x away from there. So that would mean 3x take away x is 2x, and minus 6 plus 6, well, those two will cancel out. Plus x and minus x, well, they'll cancel out as well. And minus 2 plus 6 is equal to 4. So x would be equal to 2. Now if x was equal to 2, and I put that back into one equation, it doesn't matter which one, I could put it back into this one, I could put it back into this one. If I put in x equals 2, 2 minus 2 is 0. So there's an intersection at 2, 0. Alrighty, If you have any more problems with this, I'll see you in class. I hope this helped. Bye till then.